Mr. Chacon.
Yes, sir.
We have very little as far as the question, the topic is concerned. And therefore, you want to say something today.
Yes.
Okay. You have been given the opportunity to carry us through that subheading, what is below, and then we wrap up this topic. Okay?
Changes of state. Many of the uses of the different states of matter rely on their changing from one state to another. For example, purifying water relies on a change of state from liquid to gas and back again, as does the formation of rain. The burning of candle relies on the wax changing from a solid to a liquid and then to a gas. Understanding that when things change from one state to another requires energy, in brackets heat gain, or loss is very important. Substances move from one state to another when specific physical conditions change. For example, when the temperature of a substance goes up, the particles in the substance become more excited and active. If energy is added to a substance, a change of state may occur as the matter moves to a more active state. The particle model will help you to explain how substances change from one state to another. An example of this is the changing of ice in brackets solid to water in brackets liquid, and finally to water vapor in brackets gas. Look at the diagram in figure 3.11. Explain what happens to arrangement of particles and forces holding together when energy heat increases at every state. These are saying to explain what happens when heat energy decreases at every state.
Okay, so that was a recap of what we did last, okay? Remember, we talked about the changing of states, we talked about the freezing or the solidifying, which happens when a solid is changing to a liquid. Then we talked about the boiling and evaporation, which occurs when water or a liquid is changing to a gas, and the reverse processes, their names is freezing, solidifying, and condensing or liquefying, okay? If you look through that, today we want to recap. I think we have seen that, and then we try to do this exercise. Most of our energies are going to be spent on trying to answer these questions. We are going to look at the applications of what we have just studied. Okay? Is that okay, girls?
Yes.
Okay. So we have that first question. What is the economic application of change of state? We want as many answers as possible. Angela Ikriza 1T has her arm up. Can she tell us?
Okay, so processes such as freezing, which helps us make ice, enables us to keep drinks cool, and then also processes such as condensation and evaporation aid in the distillation of alcohol.
Distillation of alcohol. Is that okay? Have you heard, girls? Have you captured what she has said? Remember with journal.
No.
We make small notes. So Ikriza, can you repeat, and you are slower? You give us your contribution.
Processes such as condensation and evaporation aid in the distillation of alcohol.
Okay, so condensation
and evaporation aid in the distillation of alcohol.
Aid in the distillation of alcohol. I hope you have heard that, girls. Next. You said something else about the heating process. That was cooling, but you mentioned something about also warming. Something about boiling. I don't know. It was something like that.
Oh, I didn't mention anything about boiling, but I said that ice is used to keep carbonated drinks cool.
And then ice can be used to keep carbonated drinks like sodas and so on. It keeps them cold. Is that okay?
Yes. Then I also have 3 more answers. Yeah. Then the process of solidification. Yeah. So then the process of solidification is useful when making ghee. as the fat, ghee or butter or cheese, as the fats attract each other to form ghee or butter or cheese. Yeah.
Okay.
Then also I found out that naphthalene mothballs are used to kill moths and other vermins at home, and these like work due to sublimation, like they change from a solid to a gas. Then those fumes help to kill moths and other vermins at home. And also processes such as freezing aid in the process of making certain dishes, for example, ice cream and frozen custard and so on.
Okay, thank you so much for that research.
Could
That's very, very good.
repeat her answer for me?
Huh? You want them to repeat the answers?
Could she repeat her answer about mothballs?
Mothballs sublime, and that sublimation is the almost a change between from solid to gas immediately. It almost occurs immediately. The liquefaction state is almost the change to the liquid is almost non-existent, or it is so short. So sublimation is whereby a solid simply seems to turn into a gas. Okay, and that process, she has said that mothballs are used to kill vermins like cockroaches and so things like that spoil clothes. Most of you have bought new things or suitcases. You have observed that there is a certain kind of whitish ball that is placed in that, and that is used for keeping vermin away or cockroaches away. I think you know what mothballs are. Is that okay?
Yes.
Is that okay, girls? Now let's look at something. We are talking about mothballs. There are some of those balls that we put in our toilets. Have you ever seen them? The water usually turns, they give a certain flavor and so on. You understand those kind of balls? You understand?
Yes, teacher.
So what is that stuff used for?
To freshen the air.
Only to freshen the air? Is that the only word used for such bowls that we place in the toilets?
Toilets and bathroom.
Yes. Air freshening,
Kill
that is
pests.
done,
Yeah,
but
those are only for them.
they also
I think
do kill what?
germs in water.
Hmm?
I think to kill the germs in the water.
So to kill the germs in water. Is that okay? Now, let me also ask you something else. And what foods do you keep in the freezer? And what is the purpose of keeping certain foods in the freezer?
We keep fish so that we can preserve it for a longer time.
Preserve them.
To preserve. So preservation, is that okay? So
Yes.
food, especially things that rot quickly, can be placed in freezers and they can be used for preservation. Is that okay?
Yes.
Yes.
Any economic application? Have you seen this fish industry? They have those freezers and so on. That kind of industry uses a lot of refrigeration in order to preserve their stuff. I hope you understand.
Excuse me, teacher.
Yes, please.
Teacher, on the economic application, when wax turns into like they make it use a candle, can it also be an economic application?
Yes, it is an economic because you are using wax which burns, and then that wax is used because that is what I think has been suggested, isn't it? So the formation of candles and so on is also an economic application.
Okay.
Excuse me, teacher.
Ice cream.
That is what?
So what about ice cream? Because they have to first freeze it.
I think they mentioned ice cream. I thought you captured that. Ice cream.
Excuse me, teacher.
Yes, please.
I need some clarification. When they tell us economic application, do they want us to find the way change of state applies in things that can help you make money?
Exactly.
Oh, okay, yes, thank you.
An economic application, you use the knowledge you have in order to make money. So those are some of the things that we are talking about. In order to preserve your stuff, for example, you're a person who is dealing in meat, fish, and so on, you have to preserve that. You fish fillet, meat, etc. And you see them in the supermarkets being kept in cool places. Is that okay? I think you have visited the supermarket. You see there are certain stuff that are kept in a freezer, like the carbonated drinks, the milk, and so on.
Excuse me,
Isn't
teacher.
it? Yes, please.
How about if you say evaporation is used in the attaining of salt, which is then salt?
Evaporation is used in the what?
The attaining of salt.
Cleaning.
Yes.
What's that word? Cleaning of salt.
Attaining. Getting of salt.
Making of salt.
Getting.
Getting.
Yes.
Getting salt.
Yes. Evaporation.
From where?
Like from lakes, e.g. Lake Catway.
That is very true. You get and then you dry that stuff until you get that stone salt, the salt in stony form. Is that okay? I think that is also correct, because that is what is carried out also. Then anything else, people? I think there are several applications of change of state. I think we have seen that, isn't it?
Yes, teacher.
Okay,
Excuse
keep
me, teacher.
widening your knowledge and then we move to
About
question 2.
candles.
About candles. How do you keep candles? Do you keep them in liquid form? Or are candles in solid state? Then you burn that wick and then that candle melts, but it is also able to maintain a fire. Isn't it? Okay, I hear nobody responding. Can we try to answer question 2? Why is it important to regulate temperature in mammals?
So why is what?
Why, you see the question, question 2, why is it important to regulate temperatures in mammals? Yes, somebody, there are 2 participants who have their arms up. I don't see them here, but I see Kirabo. Hey, Kirabo has refused. Okay, Nanyazi. Nanyazi, Ozana, you are,
Yes.
tell
Yes.
us what you want to tell us. Yes, please, you are welcome.
On number 2, teacher.
Yes.
On why is it important to regulate temperatures in mammals?
Yeah.
I don't follow on that one.
You don't what?
I don't understand on that one.
Okay. I want somebody who has understood. Why is it important to regulate temperatures in mammals? Anybody who understands, and there are 6 participants with their arms up. Who is this one? Remember, there is somebody who was not understood. So we explained who was not understood.
Mr. Sanjobe, there is someone in the chat, Primrose Mutamba. She says, teacher, what are we on? I don't understand anything.
Okay. What has she been doing in let's do things that are serious. What is the important temperatures in mammals? Girls, that's the question we are answering. Please, people, be serious. You don't know what we are doing. We are answering questions.
That is a very unserious student. Huh? Let's go ahead, Mr. Sanjobe.
Yes, we are going ahead.
Mm.
Any answers, please?
May I give a response?
I see
I'm
10
not so sure about
up, but I don't see I'm trying to look for them. I don't see them.
There is Indagano Queen.
Queen, give us the answer.
Teacher, if the body temperature is too low, the enzymes will work too slowly, which means the body processes in the body will not be carried out quickly. But if there is like temperature that is in medium, the enzymes can work at their optimum and carry out the processes quickly.
Very good answer. Thank you so much. I don't know whether anybody can supplement that answer. Why mammals regulate temperatures, but it was
There
a
is
very good
Ikiriza,
answer.
Ikiriza.
Please repeat it slowly because people are capturing are journaling these answers. We want to capture that answer. Can you try to tell it slowly so that people can capture? There are some people who claim they are not following and they don't know what you are doing. So maybe you be slower and we answer the question.
Body temperature must be maintained so that enzymes can work at their optimum and carry out processes quickly.
Okay.
Excuse me, teacher.
Yes, please.
How about if you say the enzymes in mammals work at a fixed temperature in order for them to carry out the body processes?
That is also true. It is almost the same. But it works within a specific range, not specific temperature. The body temperature must be within a given range, optimum range altogether. You can go slightly above or slightly below, but you should not exceed that temperature, I mean, excessively. It is within a certain range altogether. So that's why the mammals have to regulate their temperature to enable their organs to work at those temperatures, okay?
Teacher.
But it is within a range, okay? Is that okay, girls? I want to have more participants raising their arms up. So tell us what we can also supplement or add to that answer.
Our default is there.
Our default?
Yes, teacher.
Is
Okay,
it?
Hosanna said she didn't understand number 2. I wanted to explain it to her.
Who did not understand what question?
I'm saying Hosanna said she didn't understand number 2, so I wanted to explain the question to her and give the answer.
So we are still dealing with number 2. We are still
so that's what I'm saying.
Number 2. Yes, you give us your
Okay,
what
so the
you want to
question is,
present. Yes,
why
please.
it's important to regulate temperatures? Regulating the temperature means controlling it so that it's not too high or too low. And the importance is for proper functioning of the body and prevent dehydration and malfunction of enzymes.
That is very good.
When the temperature is too high or too low, like you said, it has to be a specific range, so not too high or too low.
That is it. So regulating is controlling. Is that okay? That's the meaning of what the word regulating. So mammals control their body temperatures to work within a specific range that enables the enzymes and its organs to function properly. Is that okay? That's the major reason how they function. By the way, can you give us one of the ways we regulate our temperature? We humans, what do we do? What are some of the things that humans do because we are part of the mammals? How do we regulate our temperature?
By sweating.
One of the functions is sweating. Is that okay?
By
Number 2?
By kunavering.
By what? By kunavering. Okay, please stick to English. Showering. Okay, showering is okay. Number 3, I want to talk about the natural things. Yes, we shower, but there's certain body things that we have. One of them is sweating. What else do we observe?
By shivering.
Shivering, we can shiver, that is okay. Anything else?
Sweat forwards.
Yeah. What body parts are really very important in this regulating of the temperature? Can you tell me about
skin?
The skin.
The skin is very, very important. Do you know how what forms the skin? The major part of the skin?
The hairs.
There are hairs. That is very good. There is fur. That's what I really wanted you to capture. That the animals have fur. They have the skin, which is basically fat. Is that okay?
Yes, teacher.
Okay. Now you are going to observe that there are so many things that animals have that enable them to regulate the temperature. And some of the things are like the skin, the sweating, you have said the shivering and so on. Those are some of the observations that you try to see that a body is actually trying to regulate the temperature. Okay, the one. Now, what do we do that is artificial to do the same thing? We now also employ artificial things that regulate this temperature. What do we do?
Like putting on sweaters on a cold day.
Wearing sweat.
You observe that we as humans put on sweaters. Is that okay?
Yes.
Okay, so it is very, very important for us to try to maintain or to regulate our temperature within a specific range so that our body organs can function properly. Is that okay? I hope that answer has been captured and we have added a little bit of some, we have tried to enrich it.
Mr. Senjobe.
Yes, Sebo?
In fact, they may also want to know or remember, or they may have heard that some animals in temperate countries where it gets so cold in winter,
yes.
Because of that, those changes in temperature, they go into that hibernation mode where they now slow down their metabolism processes and they conserve energy. So because it's so cold,
yes.
So again, you can see regulation of body temperature is becoming very important there.
Yes.
That is, yes, it either activates an animal or deactivates it because of that. So same thing to humans.
And for humans, they also hibernate slightly at night.
True.
Okay. There is an activity that I think most of us engage in, we sleep. Is that okay? That is very, very important in maintaining the body temperature. After wasting all our energies during the day, we realize that we have to regain that to conserve some energy and we always rest. Is that okay? Okay. What is a water cycle?
Excuse me, teacher.
Yes, please.
I wanted to ask whether this answer can apply as well.
Yes, please.
If there are very high temperatures in a mammal's body, doesn't that cause dehydration?
Yeah, that's why we say that's why the body has to regulate, and therefore there are certain things that you do. Some of the things that you do, you are going to discover that you take in water regularly.
Yes.
Isn't it? You shower together, or you can go into the sun. There are so many things, but the body itself has a certain way that it automatically regulates its temperature. That is through activities like sweating or shivering. Are we together?
Yes.
Okay. So I
Excuse
think
me,
maybe,
teacher.
yes, please.
But if someone is sick, what causes that body temperature to rise?
When somebody is sick, what causes the body temperature to rise?
And it's above 37.
Not usually. This one is basically, maybe I'll go more to biology, but what happens when your body is sick? What in biology, what does biology tell you? Body cells start fighting the disease. No, the temperature rise is usually a symptom that something is wrong with the body. Isn't it?
Yes.
But what is happening within the body, the moment the body starts seeing foreign agents within it, it raises up certain cells that are going to fight those agents, isn't it?
Yes.
Now, that activity, that extra activity that the body is engaged in can cause a temperature rise or a temperature fall. And therefore, the brain starts sending certain signals to the body to activate maintenance or regulating that temperature, trying to maintain it. And that can lead to shivering or feeling very hot. So those are within body activities that occur and they are better explained by the biologists. Is that okay? May I have given you a layman's explanation?
Excuse me, teacher.
Okay, thank you.
Excuse me, teacher.
Yes, please.
When it's cold and then you say a way to regulate the temperature in mammals, eh?
The what?
When like regulating temperature in mammals. When you say that getting goosebumps and then like the hair stands up to capture warmth, is it also a way of regulating temperature?
Yes, those are the activities that the body goes through. Automatically, it is self-automated. And if it is not sufficient, you end up getting even a blanket and a sweater and so on to assist the body. Is that okay?
Yes.
Okay. Okay.
It's Mr. Sanjay.
Yes, Evo.
Something about number 2. Hallelujah. Batha says, is it to prevent mammals from becoming hypothermic? Is that also correct for number 2?
Now that language, me, I have never seen it anywhere in my life. What does she mean? She should explain herself hypothermic.
Nacho, you may get to the microphone. And then also controlling the
temperature. Keep the language very simple, please. Let's keep the language very simple. Let us not become too technical and start bringing in biological terms here. This is physics.
There's also numbers, Patricia. Teacher, I still can't understand number 2, controlling the temperature. How?
That's what we're explaining.
That's what
she sweats, she puts on whatever. What is she trying to do? To maintain the temperature of the body within a specific range so that her body functions properly. Yes. That's what we're trying to say.
When they go to the beach, they remove as much clothes as possible because it is too hot in most cases. That is regulation of body temperature. Yes.
Okay. What is the water cycle? We have overdwelt on that question. If the person was paying attention, she would already have picked what you are trying to say. Can we move to what is a water cycle? Question 3, this is a primary question, primary somewhere in P before we came to secondary. I think we discussed the water cycle. There are participants with their arms up. I hope they are moving to question 3. Please, we are enough attention to question 2.
Musubika Thelma, I think.
Teacher, I think that water cycle is the path that flows, of water flows as it moves around the earth in different states.
Okay, can you give us an idea? Practically, what happens with this water cycle?
Maybe she can be assisted by Namugerwa, maybe also. Bridget?
Bridget, please try to assist us with the water cycle. What happens?
Not attentive. Chirabo Paul?
A water cycle is a cycle of processes by which water circulates between the Earth's
I
ocean,
only know the
atmosphere,
definition
and
of water
land.
cycle. So mine is
okay. Go slow on that answer so that people can capture it, please.
A water cycle is a cycle of processes by which water circulates between the Earth's oceans, atmosphere, and land.
I think that is acceptable, Mr. Chakon.
But okay.
Let's hear the repetition of the word cycle. That is maybe the only thing, but it is, she has, I think, explained what happens in a water cycle. The circulation of water between land, with the water bodies, the atmosphere, and then back to land. Is that okay? I think that's what we know about.
Let's hear some other people. Like there is Gloria Namuviru.
Okay.
According to my research, a water cycle is the continuous movement of water on, above, and below the surface of the earth.
The continuous movement of water on,
above, and below the surface of the earth.
And below the surface of the earth. I think that is also acceptable. Very good answer. Okay.
Okay.
Okay. Can you now elaborate how that water moves? Can somebody try to elaborate how that water cycle occurs, how it moves? Water moves below, above, and below the earth.
There is Unia Namuri.
So based on my research, this is how
Yes.
the water cycle occurs. Liquid water evaporates into water vapor, condenses to form clouds, and precipitates back to the earth in form of rain and snow. Water in different phases move through the atmosphere, in brackets, transportation.
Okay. Can you be slow? I think you have done a very good research. You just be slower so that your friends can capture your answers. I think they are okay, Mr. Chakonyi.
Yeah, she's there. She's spot on.
Okay. Liquid water evaporates into water vapor, condenses to form clouds, and precipitates back to the earth in form of rain and snow. Water in different phases moves through the atmosphere, in brackets, transportation.
Very good. That is briefly what we refer to as the water cycle. I hope people have captured it.
Can you please repeat what a water cycle is?
Repeat, please. We are giving people time to write. We are not writing for you people. So be slow on your answers. People can capture them and then you move on. Please repeat your answer.
Okay, teacher, I give the definition of a water cycle or how the water cycle occurs.
Give the definition slowly and then, because that question is what is a water cycle? But because most people want to know what a water cycle is, we are going to go beyond that question and give what actually happens within a water cycle. Remember, we have gone beyond the question. The question is what is a water cycle? The water cycle question should be separated, but then we try to explain what exactly happens in a water cycle. So start with a definition and then you move to what happens, okay? But be slow so that your friends can capture the answer.
Okay, teacher. A water cycle shows the continuous movement of water on, above, and below the surface of the earth. A water cycle shows the continuous movement of water on, above, and below the surface of the earth. Then, how the water cycle occurs. Liquid water evaporates into water vapor, condenses to form clouds, and precipitates back to the earth in form of rain and snow. Water in different phases moves to the atmosphere, in brackets, transportation. Well, I'm repeating again. Liquid water evaporates into water vapor.
Slowly.
Okay. Liquid water evaporates into water vapor, condenses to form clouds, and precipitates back to the earth in form of rain and snow. Water in different phases moves through the atmosphere, in brackets, transportation.
Okay, thank you so much. I hope people have captured that.
Excuse me, teacher.
Yes, please.
You can also put all that in the definition.
No.
So you can. Should I read your mind?
What is a water cycle? You should.
Yes, you can. So let me read you from what I've put.
The other one, you are describing a water cycle. The moment they ask you what is a water cycle, you should just stop at what is a water cycle. That was the first part of the question. If you go an extra mile, you will not be marked wrong, but it is not going to be necessary to answer that question. I don't know whether what I'm talking about, you understand the techniques of answering questions. Most of us, when we know what to do, we go an extra mile. Yes, please, Sebo.
No, I just want to maybe share something, just a summary of what has been described, really. But as you put it clearly, the question is what is, so which means it's a clear-cut statement of some sort, not necessarily going to the explanations.
Yes.
But for purposes of maybe interesting them.
Yes. Okay, you can clarify, Mr. Chakon.
No, just sharing, really. Sharing, because the girls have actually put it out very clearly. And I just wanted to show them a picture of the water cycle, and that's all.
Okay, sir.
Excuse me, teacher.
You can share. I don't have to unshare.
Excuse me, teacher.
Do I have to unshare, Mr. Chakon?
Yes, you may have to, sir. Briefly.
Okay.
Okay. I think, yeah, they can actually see. This is what the girls have actually been talking about. The movement of water on, above, and within or below the Earth's surface, something like that. So I think this has been really clearly captured by most of those speakers out there. So whoever still has questions about the water cycle, they can see it here in this summary. I hope it can be seen.
Excuse me, teacher.
Yes.
Can you say the definition of water cycle, that it is a process that takes place around the earth in different states?
The process, that's the what?
Is the process that takes place around the earth in different states of matter.
But this is specific with reference to water. When you put it that way of being too general about all processes, I think it is specific with water. So we're talking about water here, the different states that water goes through, you know, as it changes in the different forms. Solid, liquid, in those different states really of matter. Charity, what are you saying? Charity, we can see your hand up.
Yes, teacher, I want to ask here in the picture that you've shared, there is sublimation, like snow is changing into water vapor directly. So when you ask substances that sublime, is it okay to give snow changing into water vapor, like during a water cycle? Is it correct?
Because according to what we are seeing here, it should be okay. It should be correct, because they are indicating that yes, in those very high mountains, you can have snow changing its direction to what, you know, to those other states
that you see. Okay, I think you have been observing mist and so on. That is a very simple state of sublimation.
Okay,
so,
thank you, teacher.
I think this is sufficient.
Yes.
Okay.
I've captured the definition and the presentation. Thank you, Mr. Chakoni, for that supplement. We can now go back. Girls who have chats, please, you better speak to us, because really some of those chats we don't have, we rarely see them at times. Okay, we are going back to the questions. I think we can move to question 4. I will admit, for me, I have no idea how we make ice cream, but maybe ice cream. So let us, how can you make ice cream? Let us remove the word S, okay? So how do you make ice cream? Anybody who has an idea on how to make ice cream?
I hope the hands that are up are on that. There is a Harry Audrey.
Yes. This time, please, we are not people who have been following regularly now know what we are talking. So this time we are summarizing this topic. I hope you understand, girls. So ice cream, who can help us? May I have very little knowledge. Yes, please, go ahead.
Where in most places where I've seen them making ice cream,
Uh-huh.
usually you get milk, creamed milk, and
Yes.
mix it with your flavor that you want. You can add fruits, add sugar, whatever you want.
Mhm.
So then you put it inside no, not in the freezer, inside a film bag. Usually they use Ziploc bags where I've seen. And now you get that bag that you put the cream and all the ingredients in, and put it in another bag which has ice and rock salt. The rock salt is put there so that the ice doesn't melt easily as you are making the ice cream. So now, after doing that, you have to shake the bag. You have to make it move at least, so that the ice can mix with the cream and make it freeze little by little. So if you're making a small batch, the longest time you take making it is 20 minutes. And then if you want to do the quick way, in one bakery where I'd gone, they usually use liquid nitrogen to make it. You put all the ingredients in a mixer and pour a liquid nitrogen as you're mixing it. And then it turns into ice cream.
Okay. Uh-huh.
Kunda Vanessa, are you adding?
Yes, teacher. For me, what I saw once, how to make homemade ice cream. You first get heavy whipping cream, then sweetened condensed milk. Then you put your flavor that you want. Then they said you can put it in the freezer for like an hour or 2 hours. Then after that, again, you like get a hand mixer and mix it, like beat it very fast so that it becomes creamy. Then again, you put it in the freezer. Then it's ready to be eaten. Me, that's what I saw once.
You, our default, are you adding?
Yes, teacher. So, teacher, you get heavy whipped cream milk. You mix it with sweet and condensed milk. You add some sugar so that it doesn't crystallize, because if you just use normal milk, it will become hard like ice. So you need heavy cream. Okay, heavy cream has like the particles a little bit together. So you use that. You can either use the ice cream machine or the freezer. You put it in the freezer mostly 30 minutes. Either way, even though you use the ice cream machine or the freezer, it's still going to freeze it. So after freezing it, you get the ice cream.
Thank you, our default. Now, Rukia, are you supplementing?
Yeah, yes. Teacher, for me, what I found out is you need 3 out of 4 a cup white sugar. You need 1 cup heavy whipped cream, and then 2 1/4 cups milk, 2 teaspoons of vanilla extract, and then you stir the sugar, cream milk into a saucepan over a low temperature, and then you put the vanilla extract, and then you put in a machine.
Okay, thank you, Rukia. Then Tamari.
Teacher, I think to simplify everything, we should just say that by freezing the ingredients.
Okay, thank you. Adeke, what do you say?
Okay, I had almost the same as Shugi's explanation. Like she said, you need sugar, you need whipped cream and milk, and then you stir the sugar, the cream, and the milk into a saucepan over low heat until the sugar gets dissolved. Then you transfer the cream mixture into a pourable container such as a large measuring cup, and then you cool down the mixture and pour it into a mixing jar, like you mix it for about 1.5 minutes. Then you can take a paper teacup, and then you can add anything like vanilla extracts or butterscotch, and then you pour it into another cup and then put it into a freezer. And that process takes you about 10 minutes.
Thank you. Marjorie, I saw your hand up. Okay, she has disappeared. Thelma, once again.
Teacher, I think you will need 2 cups of whole milk, 1 cup of sugar, a 1/4 cup of fat-free powdered milk, 8 eggs, like only yolks needed, 1 cup of heavy whipping cream, 1 teaspoon of vanilla extract, 3 cups of prepared fruit, like any fruit you would want. And then the steps are freeze your ice cream maker's gel container.
We're
Heat
learning how
milk.
to make ice cream.
Okay, thank you very much. Mr. Senjove.
Can you say?
The girls seem to have enormous knowledge on making ice cream. They're ready to make money. So I suggest let's summarize this with a flow chart of how to go about ice cream making. And then I think look at the last question because we're running out of time also.
Do you have the flow chart?
Yes, I do.
Okay, girls, they are going to put a demonstration, but for me, I've captured a few things. One of the things that I've captured in that, like somebody said, we summarize everything, that whatever ingredients we have done, we undergo a certain process of removing heat from that ice cream. Is that okay? And that is by freezing the ice cream. Then there are other processes that have been talked about in our physics, like mixing and dissolving. Okay, dissolving, somebody said you heat, that increases the rate of dissolving. I hope you get the idea where the physics is employed, because now you are moving to a practical area of your knowledge. That's why they're asking you, how do you make ice cream? Mr. Chakonyi, please supplement and we move on.
Yes, you may need to unshare that a bit.
I have done so.
Thank you. So as we have here heard from our friends, there is that blending. Step 1, blending, I think where you get the liquid ingredients, and then you add the dry ingredients, whatever things they have talked about, the flavors, the milk and all that. I think we mix them. Then there's that batch pasteurization. And then there's also continuous pasteurization. So batch, you are doing it if you have just in a particular container. That is if you're going to produce a batch bit, or if you're going to do it continuously, then you either take the upper route or the lower route. And I think I see homogenization, which is making, I think, a uniform mixture of some sort, cooling. So the processes now that we talked about of physics come in here, removing the heat, the cooling. Yeah, then we see aging here, which I think storing that mixture for a certain period of time for again certain things to take place, because I think you may be having enzymes and what have you added in there. Then again, more removal of heat, we see continuous freezing or batch freezing again, depending on whether somebody has a continuous process, a continuous production of ice cream, or they're just doing it in a particular container. And then moving down to packaging, then hardening, and then storing. So basically, this flow chart summarizes what the girls have talked about in very simple terms. But I'm impressed by the knowledge that they have. You can actually see that some of them are very, very practical, and probably they're doing it at home. So I don't know what you're suggesting, Mr. Senjay, but it looks like we are done with that question.
Thank you so much, girls. I hope you can capture that. Try to find a way of capturing that. If you can take a snapshot and so on, whatever way, try to capture that flow chart. Okay? Please do the necessary. We want to move from that question. Mr. Chakunya, I think.
Yes, I share. Okay, should I share?
Yes, please.
Okay, I am already out. So look at the last question and we call it off.
Okay. So girls, our question 5. What happens when water vapor comes in contact with cold water bottle of soda? Why is it so? Water vapor comes in contact with a cold bottle of soda. You can get actually any bottle of, remove it from the freezer and you observe what happens. So can anybody tell us what happens? There are 10 participants with arms up. Mr. Chakon, I don't know whether you can see these people.
I can see them. There is Chirabo Pearl.
Yes.
The water vapor actually turns into water droplets.
The water vapor turns to water droplets. Where?
On the bottle.
On the surface of the bottle.
Yes,
that is very
because
good. On the surface of the bottle. So why is that so?
because the water vapor is hot or warm, which means that when it comes into contact with a cold surface, whereby the cold surface is actually covering a large area, the cold will start changing the water vapor into a liquid, which forms the water droplets.
Okay, that is very good. I think she's correct.
Mr. Senjobe. Maybe Paul can tell us the name of that process. What is the name of that process by which water vapor converts to those droplets?
Condensation.
Okay, thank you.
The water vapor condenses to water. That is very, very good. And what does condensation involve in terms of heat?
Mudondo.
My answer was the water vapor condenses. And the reason as to why it condenses is when this water vapor, we call it warm air, when it comes into contact with the cold bottle, it will lose its ability to keep holding the water, so it just turns into water droplets. So it sticks onto the bottle.
Okay, thank you. Marjorie, what do you say?
I also had the same answer, that when the warm water comes into contact with the bottle, it turns into droplets. So that's why the water.
Did you say warm water or water vapor? You meant water vapor, I suppose.
Yes.
Okay. Adeke Faith?
I'm answering the question that teacher Elsa was asking, and I think that condensation involves heat loss.
Condensation involves heat loss by what? What loses the heat?
Like once the warm air gets in contact with the cold bottle, the water vapor loses its heat and then it sticks to the bottle. That's what I think.
So it loses heat and condenses to form what? To water.
Yes.
I think that is the explanation, Mr. Chapman.
Yeah, sure. Okay.
Okay, girls, you have done good justice to these questions. These girls, this one, please, people, posting questions in the chat that I don't know what you are doing, etc., etc. I think you realize that a very big number of people here are very present and they know what they are doing. Please join them. That is my advice to you, so that you also become part of the people who are doing. I want to say, please prepare for that test.
Spark.
It is, I think, going to be objective numbers. Please, those who are making noise, keep quiet. I know very many people have started leaving the room. Some people still have their arms up. I don't know what their questions are. So please ask one by one.
Kirabo Hope. Kirabo is absent-minded.
No, teacher, actually, I had a question. I'm still kind of confused on this part of snow and salt. How does the salt reduce the freezing point of the snow and of the ice and then makes it melt? What process takes place in between them?
Okay, that is a later thing, but impurities can affect freezing points of water depending on whether, freezing points of substances, depending on whether they expand or contract during that change of state. So whenever any substance has an impurity, it will affect its melting point or freezing point. And for water, I think impurity is lower the melting point. So the salts, when put in water, they lower the melting point.
No, it's not that. Like,
yes.
I'm just asking, why is it? What happens when the salt comes in contact with ice? Like when they're making ice cream, it lowers the freezing point. And how does it encourage melting then? Does it accumulate heat or?
Lowering the freezing point, that implies that the temperature goes below the normal
How does
freezing
that encourage melting then? Because I'm like going through the internet and it shows me that.
Instead of forming a solid, you take a slightly longer period to form that solid. Because the temperature has gone below that temperature.
I don't think you've answered my question yet.
I don't know, Mr. Chakonya, I don't know how to
May I
answer
help
that.
her?
Yes, please.
Now, may I help her?
Yes, please,
I
you are free
think
to help.
that, yes, she's talking about how salt, like, it makes the ice melt. And when, like, we consider maybe ordinary water and we have a large amount of salt, that salt will absorb that water, thus making the ice to melt. Because salt, like, drains a lot of water from different substances.
But how does it encourage it to melt?
Note that now. Salt lowers the freezing point. And that's why the solid ice turns to water. Actually, in the developed, where there is snow, in most cases, they use a salty substance and they pour it on the road so that the roads don't freeze to become slippery. Because when the roads turn to ice or they become ice, you know what will happen? The sliding. You'll be like a skater instead of, and when you want to stop, the only way you can remove that salt is to pour a salty substance, because the effect of impurities will affect the melting point of ice and lower it. That's what basically happens. So impurities affect the freezing and melting points of certain solids.
Okay.